All right, guys, on to part 6, I believe. If you're following along in the book, I really haven't referenced the exact book, but you might know the book I'm talking about. Um, there's some parts in there that just kind of are. I'm not going to say they're pointless to do, but we're going to skip them because we've already kind of learned the tool that they're showing. The reason we're doing this one is because there is 2 tools in this one that we can show, so we're going to do this one, and we might skip a few other ones if I can't decide that there's an actual reason to go over them. So with this part here, we can see the origins kind of hanging out in the open here, as if this sketch here was drawn and the origin point was made horizontal and vertical to these 2 points at a distance. So we're going to draw it just like that, and we're going to sketch it and we're going to extrude like that from the mid plane to get our part looking like this. Now you could sketch on the front plane, make a 100 by 75 block, push it out 100, and then you could make all of these cuts. But that's like we've talked about, we want to think about the part ahead of time and use the tools we know, and we want to make things faster. So with less clicks, this one would be done best sketching on the side plane, the right plane, or the left plane. Technically, right plane's best, and then extruding mid plane, and then just making the one cut out of this. See what I mean? Because you could get the entirety of the sketch of the whole profile in one view, and then you only need to make one edit. So that's the faster way to do it, and that's how we're going to do it. So let's pop over, we can do part, millimeters, sketch, let's hit that right plane, and like we said, it's not coincident to the origin. We do know it's kind of like this shape, though, if I'm remembering right. I think it did come over a little bit, then it came down. Yeah, I didn't connect those. Control click, coincident, or trim the line and redraw it however you want to do it. So with this one, right, let's hit these 2. They should be vertical, and this one should be horizontal. Now that kind of puts these dots at our origin, but it doesn't tell us how far. Let's look at the drawing, figure out what we need. Let's go to the big dimensions first, 75, 100. But that's technically not correct. We need, no, that is 75 and 100. Yes, because both of those are 100. So I kind of double looked at that line if you were seeing what I was seeing. Okay, so we know this is 100. And I saw this was 80. And then this was 75. Cool. 75, 80, 100. Technically, I think it's this one. Yeah, because it's the height, and this is the length, and we haven't done length. So now we need 35 tall here, a 45 degree, and that should give this distance, I believe. So that should fully define all those parts, and then doing that angle should fully define the rest of it. So let's add those 2 angles in. So we said from here to this 45. Yep, and that fully defines it. I think we've talked about that in a previous video. Oh, and you can see an error I've made here. Let's cut this. This comes down to like here. It's more like that, right? Because we have to add a dimension to that shelf. And now the only thing we're really missing is this angle, and I think we are. Well, it's not gonna fully define it because we don't know the length. And I know what my brain was thinking when I did that, so I can tell you. And oh, not that. It's going to show you in this image what we're kind of seeing, right? This is definitely vertical. And if it was off by a couple millimeters or so, they would put that dimension in, or I would. So when a dimension isn't in like that, you can, like I've mentioned before, you can make some assumptions. In class and in drawings I've seen from places, they won't make you make any assumptions. They'll give you everything. So when I say that, assume it's a rarity and you're not seeing what you should be seeing, to be honest. But in parts I've seen online and parts I've done myself, and just random stuff I've designed to practice, I have noticed that they'll do that. They'll do stuff like that where you might need to make an assumption based on what it looks like. And if it looks vertical, and it is, well, add the vertical and then check the weight and see if you're on. All right. like we said, this is going to be the easiest way to get this generalized shape, and it was, right? And that looks pretty good compared to our ISO. We just need to make that one cutout. And the beauty of how we've made this, and what we've talked about with some other sketches, you can sketch on this outside plane, and then you could draw the triangle that we're going to need to cut, and we could offset the cut into the part, and then we could begin our cut to the length of the cut. That already sounds complicated. Now, I'm going to show you that really fast just because I talked about it and it seems like something we could do. But it's not a tool in our tool belt that we're really going to want, right? And there's also another tool I could have used right there, but we're going to talk about that when I want to talk about it. So, like I mentioned, we could offset this cut. Offset. And I think it's 25. It's offset that way. And then the cut we already talked about was 50. So we could make that cut that way. There's multiple ways to, skin a cat, so they say. Bad phrase, but legitimately there's multiple ways to build any of these parts, and learning how to build them the fastest and the smartest is really what's going to make you the best designer and best engineer possible. And that was one thing that did frustrate me in my classes, because the teacher did say that in the very beginning of the class that all these parts could be designed. Sorry, actually, I should explain that before I do that. I'm talking about something else. Let me finish this train of thought and then we'll continue. He didn't really get into showing you what the fastest ways were often. He assumed that with the tools you had in your belt, you would apply those faster ways. But some people need to be shown how to do, diff EQ or, long form equations. They can't just see it and take things from their old math classes and go, oh, I can do this. So just because you have the tools in your belt doesn't mean you can complete the project. Sometimes you need a master craftsman ahead of you showing you what they have seen and what they've done and what's easier. And I'm not going to say I'm a master craftsman or anything like that in this, but I do know some things that make things easier. And we're going to apply one of those here. So let's get back on the topic and think about what we just did earlier. We sketched here. We clicked a bunch of buttons to offset that sketch, then to set the distance, then to cut it in at the right thing. A lot of clicks, right? So let's look at it this way. We have this drop-down menu. When we sketch, it wants to know what we're going to sketch. We clicked here before we could click anywhere. But let's click here, bring the drop-downs. Let's choose that same plane that we started on in the very beginning. Now, I know this looks exactly like what we just did, but it's not, and you'll see when I do this. See where that line is? It's on that center plane that we mid-planed from within the part. So let's put another tool in the tool belt now. We have offset and convert entities. Offset we'll learn a little later, but it's very similar to convert. Essentially, it's going to convert entities that are already there, like these two edges, into your current sketch. So I've clicked them, I've added them. Now we've converted them into the sketch. And you see how that fully defined it too? It's a really good tool. Our other one wasn't fully defined, if you remember. When I did that line there and then drew these over here and overlaid them, it wasn't fully defined. If I would have converted entities, it would have been, but we weren't showing that at that point, and this is what we want to show. So from here, let's get back on topic again. Let's think about what we're doing. We're extrude cutting, and it would be from mid plane because that was the last thing we had used, but I had shown you the other way. Look how simple that is. That's a lot less clicks, right? 1, 2, entering the value there, 3, setting the distance here, 4, versus just 1, entering the distance, right? Or I guess technically 2. 1, 2, setting the distance. So we cut out a few clicks in this method, and our sketch is fully defined using the convert entities tool. All right, there's our tool. There's our part, and where's our origin? It's sitting out in free space. So cool. Easy part to design, really. Only 2 cuts, but a few things that we could talk about in there that make things easier. The convert entities tool, and picking which plane or surface to sketch on when we're thinking about the relation to our drawing. All right, that's all for this part, guys. I appreciate it. Like in the last ones, we're going to put the mass properties, and I think I've been saying in the comments. I'm not going to put it in the comments, guys. I'm going to put it in the description. I'm not really like a YouTuber or anything like that, but I do make videos. So we'll put it in the description. The last, I think, 4 parts all have the mass properties in the description. So best practices, like we always end on, see the drawing, pause, try to make the part yourself with the tools you have in your belt. You might not have all the tools for this one, or it might be more difficult, but you could do it. Check the mask properties. If you fail, go back, watch the video, see what you messed up on, check again, see that you got it right, improve. All right, if you guys have any questions or anything like that, or if I screwed up, yeah, you can leave them in the comments, but I'm not going to ask you guys to like or subscribe or any of that crap you've noticed in these videos. So we're not gonna do that. I'll just make a quick note of that there. If you've noticed we don't ask, that's for a reason. Thanks.